Alrighty, let's have a look over these here. Okay, so for question number 1, okay, we've got ammonium bromide. All right, so we got 1 nitrogen, 4 hydrogens, 1 bromine, okay, and we're looking for how many moles there are in 200 grams. So you can give them a mark here first for their givens. 200 grams was the mass, little m, okay, and the molar mass can be calculated. 1 nitrogen, 14.01, okay. 4.04 is our 4 hydrogens, okay, and our 1 bromine, 79.90, giving us a total molar mass of 97.95 grams per mole. Now we're asked to solve for number of moles, which is n. Okay, we have little m, we have big M, so we plug them in. So you can give them a mark if they showed that step. 200 grams over 97.95, or if they just had even the mole equation, okay, because it didn't need to be manipulated for this one. All right, and that should give us an answer of 2.04 moles. Have a question? No, they got to have what I've got there or not. Okay, so 1 mark for givens, 1 mark for showing this step, 1 mark for showing the final answer. Okay, and guys, they've got to have units. If the final answer does not have moles, okay, it's wrong. Okay, it's got to have the right units. Okay, any questions on number 1? Okay. For question number 2, we're being asked to find little m, mass. We're told we have 12 moles, and we're told that it's iron 3 bromide. Okay, so give them a mark for their givens. N was 12 moles, and we got to calculate the molar mass of iron 3 bromide. Iron's 55.85, and here's our 3 bromines, 3 times 79.90, okay, and that gives us a molar mass of 295.55 grams per mole. Okay. Now, if I want to solve for little m, I've got to move big M over to this side, and I do that by multiplying by it, because if I want to move something, I do the opposite, and right now I'm dividing. So I multiply that. Second rule of algebra says, what you do to one side, you do to the other. So we got big M times n gives us little m. All right, so mark for givens, mark for the manipulation. Okay, so they have m equals n times big M, or big M times n, doesn't matter. Okay, and then a mark for plugging in the numbers. 12 moles times our molar mass, 295.55. Okay, mark for that. And then a mark for the final answer, 3,546.60 grams. Make sure that the units are right, or that they have units on that answer. 6 is fine. Yeah. Hey, any other questions on number 2? All right, our last one. This one involves Avogadro's number. How do we know that? It's got molecules in it. Okay, this time they gave us the number of molecules. Right? We can use the number of molecules along with Avogadro's number to solve for the number of moles. Okay, the number we have divided by Av's number gives us number of moles. All right, first mark, calculating the molar mass of lithium sulfide. And I told you that this is how I'm going to give you those compounds on the test in name form. All right, so lithium sulfide is Li, this is a +1. Sulfide is a -2, so this is Li2S. Okay, so we've got 6.94 times 2. There's our 2 lithiums. Here's our single sulfur, 32.07, giving us a molar mass of 45.95 grams per mole. Okay, so 1 mark if they have that. Our next step, we have to calculate the number of moles. We take the number of molecules we have, we divide by the number of molecules in 1 mole, and that gives us the number of moles. So if they have that step, 1.5 times 10 to the 25 over 6.02 times 10 to the 23, okay, you can give them a mark for that. Whether they got the answer for that part right or not, if they showed that step, that's a method mark. Okay. All right, once I have the number of moles and the molar mass, I can calculate little m, exactly the same way I did in question number 2. So I manipulate this by multiplying both sides by big M, okay, to get little m equals n times big M. All right, so if they've got this step, or they have the numbers plugged in, okay, we're going to just give 1 mark for that, but on a test I would give that. You know what, let's just change that. 1 mark for the manipulation, 1 mark for the substitution. Okay, 24.917, our number of moles multiplied by the mass of 1 mole, or molar mass, okay, should give us 1,044.60 0.93 grams. Here? 9.5. Yeah. Okay, so that one will be out of 5. Yeah, okay, I plugged in this extra mark here. Okay, if they showed the manipulation of the mole equation for M, then another mark for the substitution, because that's the way I showed you I would do it the last few days. What did they round? No, they must have messed something up somewhere. They rounded off up here or something. Do this one here as the example. Okay, we want to keep all of our decimals till the end because it makes a big difference. When I did this, was it 1.5 times 10 to the 25? Okay, and I divided that by Avogadro's number. Okay, 6.02 E23. Okay, I get quite a few decimal points after that. Okay, now I want to keep those because they're important. They're part of the accuracy of the numbers that I used before, right? If I round off right now to 2 decimal places, I get rid of all of these numbers. And when I do my other multiplication operation, it's going to change my final answer by a fair amount. Okay, so I want to keep those, multiply that by my 45.95. Okay, and I get 144.93. But if I round that number off to 24.92, and then I do that operation, I get a significantly different number. Okay, and that's going to be something that's going to follow through into chemistry, bio, and physics 20. Okay, is that we always keep our decimals until the very end, and then we round for our answer. All right, so just get in the habit of doing that. Okay, a lot of people have said, well, then I got to write this stuff down. Well, no, you don't. Just put times, and it'll put the answer from the last step in your calculator with all the decimals. Okay, and then you don't have to worry about keeping them all or having them all written down. Okay, your calculator will store them. Okay, or put it into memory. Go M plus, and put it into memory so it stores that number with all the decimals so you can use it later. Okay, everybody with me there? But it does, as you can see here, affect your answer. Especially when we're dealing with big exponents, it can really affect your answer. All right, so that one is going to be out of, we said this one was out of 5, so 912. Yep. Okay. So give them a mark out of 12 right at the top and pass it in, please. Okay, so what we're going to do is go over, basically, I'll talk about what kind of things are important along the way. Okay, in this unit, I'll tell you whether that's going to be multiple choice or written response kind of material, okay, and give you some ideas, marks, for each thing and stuff like that. But one thing I do want to bring up, because I had some kids in my physics 20 classes here who had some trouble with this the last little bit. I give you the quizzes for this class ahead of time. Okay, so you get a chance to go over them and take as long as you want and then write them the next morning. Okay, that can give people a false sense of confidence in their ability to do the types of questions that have been on the quizzes. Okay, like I always say, go back and look at your quiz marks. If you did poorly on one, you should go over that stuff. But that doesn't mean you shouldn't go over the stuff you did well too, right? Because that situation where you get it ahead of time is a lot different than what you're going to have on Monday, which is questions you haven't seen before. You'll have seen those types of questions before, but not exactly those questions before. So a lot of times people just say, well, look at my marks. I mean, I'm already doing great. And you are, but does it mean necessarily that you know it as well as what your mark says right now? Okay, because sometimes your mark can get a little inflated with those quizzes. Okay, you're going over the review sheet and the answers are on there, right? So you're looking at the key and you're going back and forth and you go, I know this, I know this. But what sometimes happens is people look at a question like, I'm not really sure how to do that. And then they look at the key. Oh, that's how I do it. Oh, that makes sense. But you didn't really know how to do it. And unfortunately, now you're telling yourself you did. But it's different. The answer's not going to be on the test on Monday. You're not going to be able to look at that and then work backwards. Okay? Again, it sometimes can give you a false sense of security in that, well, I know how to do this. And then you get to the test and you're like, oh man, I really don't know this stuff as well as I thought. That's not the feeling you want to have on Monday. Okay? So if you find yourself doing that, where you're looking at the answer and then working back, you don't understand that stuff very well. Okay, and you should really spend some more time on it. Okay, come in and see. Well, you're not going to get much chance to see me now. Okay, because tomorrow's Friday and there's no scheduled help. Okay, and you write test Monday morning. So, yeah, we didn't see very many people this week, unfortunately. Okay, so make sure you're doing that test on the weekend, but do it, then check the answers. Like, do the test, that practice test, do the whole thing, then mark it with the key. That'll give you a better idea of how well you really know that stuff. Okay, and then look at what things you did well and what things you didn't do well. Okay, make sure you go over the things you didn't do well, because there's also a tendency for us to go, yeah, I'm good at this stuff and I like that feeling, so I'm just going to keep doing that, and then we don't do the stuff we're not good at, because I mean, it's human nature, right? You don't want to do the stuff you're not good at, okay, because that sucks and it's not fun. Okay, but unfortunately you do have to do that. That's how you get better at it. Okay, so those are just little study suggestions for you for over the weekend. Okay, first thing we went over, okay, in this unit was atomic theory / history of the atom. Okay, that's going to be mostly multiple choice stuff. I might show you pictures of atomic models and ask you maybe whose it was, or what role it maybe played in the development of the atomic theory. Okay, like if I show you, for example, Dalton's solid sphere model, you would say, well, this is what people thought at the beginning, because they didn't really know about electrons and protons. Okay, whereas if I show you Rutherford's nuclear model, you would say, well, that one's important because he did that foil experiment where he found that there's actually in the nucleus, but the nucleus is a lot bigger than he thought it would be. Okay, and things like that. So kind of look over those, okay, just so you understand kind of there's about 5 models in there that you should be able to recognize at least for a multiple choice question, okay, and kind of why they were important. In terms of the atomic theory, there's 4 points to the atomic theory. Okay, everything's made of atoms. Atoms of the same element are the same. Atoms, different elements are different. Okay, atoms combine in simple whole number ratios, and reactions occur when they're separated, joined, or rearranged. It's important for you to know those 4 points. Okay? I mean, yes, there's probably going to be a multiple choice question like which of the following is not one of his points, but there's also probably going to be questions that will check your understanding. Okay, and we used one of those points in our hypothesis for the reactions lab. Okay, we said if a reaction is when atoms are separated, joined, or rearranged, then we can do that. Well, there might be questions that ask you to apply that a little bit. Maybe if I'm asking you about your understanding of a reaction type, okay, or something like that. Okay, so this will be mostly multiple choice stuff, but it could be part of explaining something in the written response as well. Okay, so like we said, know the points and models. All right, then we talked about naming compounds. And writing their formulas. How important is that? It's really important, okay? Not because there's going to be a ton of questions about what's the formula for this stuff, or this is the correct formula for this material, or certainly, yeah. There's going to be some multiple choice questions that are going to be like that. I'll give you a formula. What's the proper name for this thing, A, B, C, or D? Okay, or here's the name. Which is the proper formula, A, B, C, or D? Yeah, there's going to be a few of those. But it's more important in that if you can't write formulas properly, you can't write reactions properly, you're not going to balance reactions properly, you're not going to predict reactions properly, and that's where the big marks are. Okay, so it is important that we know how to write the formulas for compounds, name compounds properly, okay, all that kind of stuff. So certainly go over that, okay, so that you are confident in your ability to write the names and formulas. Okay, remember that the big things there are the differences between the rules for molecular and ionic compounds. Okay, ionic are metals and nonmetals. Okay, or polyatomic ions, right? As soon as you have a polyatomic ion, you know it's ionic. Okay, whereas if it's molecular, okay, we got 2 nonmetals. Okay, the naming is similar. You write the first one first, and if it's an ionic compound, it's the metal first, and it's the non-metal second. Okay, if it's a molecular compound, it's whichever formula is first, and then whichever one is second. Okay, we use prefixes for these ones. Okay, and we sometimes use Roman numerals. Which one do we use Roman numerals for? Right, the special metals, the ones that are we call multivalent, okay, that is they have more than one possible charge, okay, so make sure you recognize which ones those are, and that's actually something that does come up a few times and tricks people on the exam, because you're pretty familiar with your periodic table now, and you don't always look at it anymore because you remember that iron is Fe and you just kind of start writing it. Always look back anyway, okay, especially if you're writing a formula, and double check that that isn't a multivalent metal. Okay, and might have more than one possible charge, things like that. Okay, so always just double check, okay, when you're looking. All right, and then obviously for ionic compounds, when we're writing formulas, okay, we swap and drop. Okay, do Roman numerals go in the formula or the name? The name only. Okay, we put them in the name so that we know which charge to use when we write the formula. Okay, but they don't need to go in the formula. So that's really about all there is with naming, okay? It's more that you need to be able to do that to do other things as opposed to for its own sake. There might only be about 5 or 6 marks where it's just, what's the name of this stuff, okay? That's not a big part. Okay, and then we talked about properties of compounds. Okay, specifically that was physical properties. And that's lesson 4. I'd have a look over that. I'd also have a look over that first lab. Because what I'm going to do on the test, in probably the multiple choice, but maybe there might be some stuff to do with this in the written, is describe the physical properties of something. And then you would have to pick from the choices in a multiple choice question which compound you think it is. Okay, so let's say I tell you that I've got a clear liquid with no discernible odor that has a pH of 7 and a conductivity of 0 that is soluble in water. It's water, okay? Right? We would know it's molecular because it didn't conduct electricity. It's neutral in pH because it's 7. Water is obviously soluble in itself, okay? And it's a clear liquid with no odor, right? It could be something like that, right? Now, I would probably pick something, reasonably obvious, but, I would want that process in there that says, okay, I remember that all ionic compounds conduct electricity in solution, but molecular ones don't, okay? I will certainly have questions that would test that. Okay, so you certainly need to know that part of it, so be able to identify. So there's going to be some in the multiple choice, but there could also be, it could be part of an explanation for a written response item as well. Generally, guys, anything that we took time to do a lab on is something that's probably going to be focused on. Okay, and then we talked about solubility. Okay, certainly know your terminology. Okay, like precipitates. Okay, soluble. Okay, insoluble, solute, solvent. Make sure you know those, because there could be multiple choice questions that test whether you understand or know the definitions essentially of those terms. And you're going to be asked to use your solubility chart. Okay, in almost exactly the same way you were asked to use it in question number 2 of the reactions lab. Okay, I give you a reaction and I ask you which of the products, if any, are soluble. So you look and you see, okay, this one, is not soluble when it's with this, so that's a precipitate. This one's soluble. Okay, you certainly are going to be asked to do something like that. Okay, also there's going to be an apply your knowledge question in the written response about solubility. There's one kind of like, there's one in your practice test. Okay, that's kind of like that, where it's asking you to apply what you know about solubility to solve a problem. Okay, so it'd be something like that. Okay, which is, those are difficult questions because they're asking you to really take what you know and put it into use in a new situation. Okay. All right, so that could have something to do with, precipitates and whether something is soluble, and it could also involve reaction types, okay, things like that. Okay. Then we talked about the polar nature of water. We didn't spend a lot of time on that, but you do need to understand the polar nature of water. Okay, there's going to be a written response item about being a polar molecule. Okay, so remember that we said water is a polar molecule, okay, because the charges, the electrons, are not shared equally. So the electrons spend more time down here on the oxygen than they do up here on the hydrogen, and that causes this end to be positive, this end to be negative, and then other water molecules come by and they're attracted to the positive ends, and they form those hydrogen bonds, that surface tension and all that kind of stuff that we talked about that day. Okay, so make sure you know what a polar molecule is, okay, and that you can explain that. Okay, and maybe some applications of that. We talked about how it's useful for plants to transport water to the top of a tree. Okay, we talked about these two terms, adhesion and cohesion. Okay, they have to do with these hydrogen bonds. Okay, so I would certainly make sure that you cover that kind of stuff. Okay, we actually covered this when we were doing our lab design, but I forgot to mention it up there. Scientific method. Okay, what I mean by that is variable types. Okay, so if I give you an example, like if I describe an experiment to you, I might ask you in the multiple choice to identify which thing was the manipulated variable or which thing was the responding variable or things like that. Okay, so you certainly need to know the variable types. Okay, and the notes you have on that were when we were talking about how to assemble a proper lab report right before we did the properties of compounds lab. Those will probably be handwritten notes, okay? They wouldn't have been in the notes package. I had you handwrite those ones. Is he? Oh. Okay, next thing, then we got into reactions. If there is one thing on this test that counts for more marks than anything else, it's reactions. Okay, because chemical reaction will basically test all of the skills I need to know, okay, from this entire unit. Naming, formulas, balancing, predicting, all that stuff is all going to be tested on your exam. Okay, and you've seen on the practice test how I'm going to do that. Okay, I've got some questions that are just balance these reactions, fill in the blanks. Some that are write these reactions out in formula form and balance and identify the type. And others are, here's half of a reaction, predict the products. Okay, that's all going to be on there. Okay, and it's big marks. A prediction question, one reaction is 4 marks. Okay, one reaction would be 4 marks. Writing it out in words and identifying the type could also be a 4-mark question. Okay, one for the reactants, one for the products, one for the type, one for balancing. Okay, things like that. So make sure that you can do that. You've got lots of worksheets on that that you can use for questions as well as that review package. Okay, so that is the thing. If I was going to spend more time on one thing, spend it on that. Okay, I would say that that is likely to be just under half of the marks in the test. Okay, so it's big. Okay. Now, I don't mean that every question is specifically about reactions, but reactions might sometimes work into a question, like in a multiple choice question or something like that. So, okay, you could have some multiple choice, but mostly this is going to be written response. Okay, if there's a multiple choice question about reactions, it would be like, which of the following reactions is a single replacement reaction, A, B, C, or D? Okay, stuff like that. Okay, so certainly that's the biggest part. Okay, and then the last thing we covered was the mole equation. All four. Okay, there's one of each type. Okay, and I've gone over one of each type every day except today. I only went over 3 of the 4 today from the quiz. Okay, but tomorrow I will go over another 4 examples, okay, in class at the start of class. Okay. Doesn't seem like, seems like we did more than that, but when it comes down to it, a lot of the stuff we did was building towards the last 2 things. Okay, we had to have all those kind of prerequisite skills to do the reaction stuff. Okay. All right, so numbers on your test here. Okay, so we are looking at 33 multiple choice questions. Okay, and I've already kind of told you the things to expect in there. Okay, it's a lot of recall kind of stuff, terminology and properties of compounds and things like that. Okay, so they go generally pretty quickly, the multiple choice. Okay, and then we are looking at 6 written response items. And yeah, they're basically just like the ones that are on your practice test. I'm going to ask you to do some balancing. I'm going to ask you to predict the products of a chemical reaction. Okay, I'm going to ask you to do some mole equation stuff, ask you about water, and ask you about solubility. Okay, and one other thing I'm going to ask has to do with the structure of the atom. Okay. I would suggest you be able to draw me a picture of an atom as we would currently view it today. Okay, so you're looking at unit 1 there. Okay, be able to tell me if I give you a specific element that you could draw me a picture of what that element's atoms would look like. Okay, including all the particles within the atom in the correct numbers. Okay. All right, questions? Anything you would like me to go over? Okay, so adhesion and cohesion work like this, okay? Adhesion is a hydrogen bond between water and something other than water, okay? So if we're talking about the inside of a tree trunk, okay, and I've got a water molecule, okay, this positive end could be attracted to a negative molecule within the trunk of the tree, okay? Positive attracts negative, and we form a hydrogen bond here, okay? That's adhesion because they stick together like an adhesive, right? Okay, cohesion is when water sticks to water. So the positive end of one forms a hydrogen bond to the negative end of another. That's cohesion. That's what makes surface tension on liquids, on water specifically. Yeah. Okay, what else? Okay, well, you've got your practice test, you've got your review package, Still have a couple of mole equation worksheets probably not everybody is done. Okay, let's work on those things for the remainder today. If more questions come up that you would like me to answer or something you want me to show, okay, this is our review day, so it's the day to ask. Carson? We'll do that in schedule help. I want you to do your review now. Okay.